All right, so in this example, we are given a function and its equation. We're even given its graph. And what our job to do is to take this function, our original f of x, the principal square root of quantity x plus 8 minus 6, and we need to find its inverse function and its domain and range. What I want to do first is kind of start with this guy right here, and I like to find its domain and range first. So the first thing that I notice is that we've got a radical here. And this is a real valued function, meaning we want to have real valued outputs, which means we don't want to be taking the square root of negative numbers. So I want to make our entire radicand a non-negative number. I want it to be at least 0. So I'm going to set up the inequality x plus 8 is greater than or equal to 0, which means that our input values must be greater than or equal to negative 8. So I'm going to say that the domain of our original function f is going to be all numbers greater than or equal to negative 8, which is confirmed graphically. Note on our graph, it kind of terminates right there at the x value negative 8. Our function does not even exist for any x values to the left here, because if you had an x value less than negative 8, you would not get a real valued output back. Now the range of our function f of x, we can do in a number of ways. One is a little bit more intuitive, and it says, listen, this quantity right here, when I take the principal square root of something, it's either going to be 0 or positive. It's going to be a non-negative number. So when we're thinking about possible outputs that we can get for all of these inputs, well, I think you're always going to have at least negative 6 and then maybe something more. So I think the possible outputs that we could have for our function, the range of outputs, are all outputs that are greater than or equal to negative 6, which is, again, confirmed graphically. This right here is where our function seems to terminate, and it has a y value or an output value of negative 6, and it can only get higher. As we go on and on and on, this function just continues to grow and grow and grow slowly, but it goes forever and ever and ever. All right. So we've got our domain of our original, we've got our range of our original, we even have some ordered pairs on our original that I'd love to highlight. We've got the ordered pair negative 8 comma negative 6, negative 7 comma negative 5, we've got negative 4 comma negative 4, we've got 1 comma negative 3, and we've got 8 comma negative 2. It's just good to have these in mind. All right, so let's find the equation for our inverse function. The strategies that we have for finding this right now are really either to do it kind of intuitively and undo everything that f does, or well, let's start that way. So I think our original function f, I think that it takes its input x, and it first adds 8 to it. I think then it takes the principal square root of whatever that is, and then I think to arrive at f of x, it subtracts 6. So there is f of x for you. So now our inverse is going to have to undo all of these things. We'll do this in green. So our inverse function is going to have to first, well, let's make this a slightly darker green, shall we? Our inverse function is going to have to first add 6. Then it will have to square whatever it had. And then at the very end, it'll subtract 8. So now when we're thinking about our inverse function of x, well, I'm going to kind of build this from the inside out. The very first thing that our inverse function needs to do is add 6 to its input, so x plus 6. And then it needs to square that whole quantity, right? That's what we said. And then at the very end, we've got to subtract 8 from our output. Awesome, awesome, awesome. There we go. There is our inverse function, f inverse of x. This is fantastic. So now we say, okay, well, what does it look like? And what is its domain and range? Well, we already know what its domain and range should be because we did that for our original. So we can go ahead and confidently say that the range of this function, our range of our inverse, is going to be exactly the same as our domain of the original f of x. And the domain of this inverse will be the exact same as the range of our original function, which is -6 to infinity. Now, immediately, we say, wait a second. At face value, if you were to just look at a function's equation and see that, you'd say, listen, no denominators, no radicals, no problems. The domain should be all real numbers. But because we are considering this function's equation as an inverse, we got to be careful. Right? This function right here is going to inherit this domain restriction by the range restriction on the original. In order to be an input to your inverse function, you have to have been an output to the original. Otherwise it doesn't work. And so this also has implications with regard to the graph. So don't say, well, what does this graph look like? Well, we got some options. We already know that this should be a parabola, upward facing with vertex -6, -8. We can also do that by taking this ordered pair right here and switching it to -6, -8, which is going to be right smack dab in the middle of that writing. So I'm going to just move this a little bit. Awesome, -6, 1, 2, 3, 4, 5, 6, -8. We should have the ordered pair -5, -7. I mean, these all are going to actually make that statement true, which is great. We could, find these by plugging in inputs in this function's equation, or I'm just really reversing all of these guys. The point -4, -4 should stay exactly where it is. Awesome. We should have -3, +1, and maybe -2, +8. Oh, I think that's going to go off of the graph, alas. And so we've got a sketch of our inverse function here. And now we say, wait a second, and note to self, normally we would expect this graph to continue on in the other direction. We would expect it to kind of become a full parabola of some variety. But because we have this domain restriction right here, we only get half of that parabola. And note that this guy is definitely going to be symmetric about the line y equals x, which I think is pretty, well, that's not a very good one, which I think is very, very awesome, right? There is our line y equals x, and our graph is completely symmetrical about it. The only ordered pair that stayed exactly the same was right here at -4, -4. And that's exactly how we go about finding the inverse and its domain and range and going ahead and graphing it. And I'm going to offer one more way to go ahead and find the inverse as well, which is if we are given this original equation, f of x equals the square root of x plus 8 minus 6. Note that we've got our input right here and our output right there. The inverse function, all it does, it says, hey, given the output, how can we find the input? So what we're going to do here is we're going to use this exact same equation and we're going to solve for x in terms of the output. So for instance, I'm going to add 6 to both sides. I'm going to square both sides. So f of x plus 6, this whole quantity squared, equals x plus 8. And I'm going to subtract 8 from both sides. F of x plus 6, quantity squared, minus 8 equals x. And so we say, hey, you want to get your original input? This is what you do to your output. And so we say, well, check it out. This is just a rule right here, which says, hey, what do you do to your thing? Add 6 to it, square that quantity, and subtract 8. This right here is our inverse function. These are the operations that it performs. This is its rule. So it says whatever its input is, which happens to be the output of our original f, you add 6 to it, square that, and subtract 8. So that's another way to find our inverse function. And then one more thing about this is note that there was some kind of domain and graphing kind of weird stuff going on here. What's the deal with that? Note that if we compose these functions together in one direction, everything is groovy. But if we compose them in a slightly different direction, it doesn't work out as well. So note that if we did, for instance, f inverse of f of x, so f inverse of f of x, right? We know that when we compose them together, we want this to just be x. That's what it means to be inverse functions. Well, f inverse says I'm going to take my input, add 6 to that, square it, and subtract 8. So what is the input, though? Our input is going to be this entire equation up here. So we're going to have the square root of x plus 8 minus 6. All right, now that's our input. And f says, what do I do to this? Well, the first thing I'm going to do is add 6, then square that, and subtract 8. So here's the deal. These two are going to add to 0. That's awesome. So we get the square root of x plus 8, quantity squared, minus 8. Looking good. This is awesome. And we get x. Life is good. That means that this inverse function is definitely the inverse of that function right there. Now, it's really interesting that imagine that this guy in green was our original, and we wanted to find its inverse. Then we'd run into some sort of trickier problems, because note that when we compose them in a different direction, weird things begin to happen. So if I did f of f inverse of x, right, what we'd have then is, I'm going to have to go to another line. Well, f inverse of x is this whole guy right here. So I'm going to put that entire equation in. X plus 6 quantity squared minus 8. And now this whole guy, what am I going to do to that? I'm going to add 8 to him and take the square root of that. So I'll do this in black lettering. Add 8, take the square root of this whole thing, and then subtract 6. Well, let's see, these two guys are going to add to 0. That's pretty cool. And we get the square root of x plus 6 quantity squared minus 6. We just get an x plus 6 minus 6 equals x. Hurrah, life is good. But note what I had to do. I had to fudge this step right here. Because we know from back in the day that when we take the square root of x plus 6 squared, we actually get the absolute value of x plus 6. So that is intimately related to the fact that if we started with a full parabola up here, if this guy was a full parabola, and we took its inverse, the inverse would definitely have a portion that looked like this, but you know what else? It would also have a portion that looked like that. And our inverse would not be a function. So something to keep in mind. Definitely laid out the general strategies for taking care of these types of problems right here, and also kind of opened the door for some really interesting and meaningful conversations about how these inverses behave and when they work really well and when they don't work so well.